is the chapter review for Physical Science 8th grade, Unit 2, Chapter 3, regarding energy. All right, first thing of note is to be able to define the word energy. Okay, energy at its most basic level is the ability to cause change. Everything in the world involves energy, and energy takes many different forms, has different effects, and it has different conversions and changes that happen within it too. All right, next thing is forms of energy. The first one we're going to talk about is mechanical energy. Okay, now mechanical energy, it's the energy that moves objects. So anytime you're trying to move something, say you're picking up a book off your desk or you're moving your pencil, that is a form of mechanical energy. Okay, next up is sound energy. This is vibration of particles in solid, liquids, or gas, and that's what actually causes the sound to happen. When you hear something like drums beating, right, you're detecting those vibrations that are occurring, and they actually come through the air. The big thing to remember about sound energy is it cannot travel through empty space. Cannot travel through empty space. And next up for this page is going to be chemical energy. Chemical energy is energy stored in matter. So the amount's going to vary depending on the arrangement of the atoms. Okay, so an example of this is when we have gasoline that burns, and that's going to cause a chemical energy to be produced as heat. Also, in your cells, in your body, the chemical energy is stored in the foods you eat. So this comes from foods, and it also comes from other things like gasoline and so forth. There are 3 other forms of energy. I'm just going to run through these 3 really quick. There's thermal energy, electromagnetic energy, and nuclear energy. Okay, thermal is when the molecules and atoms, as we know, they're always moving. That motion is a thermal energy. Electromagnetic energy is the energy used, such as like in a microwave or an X-ray. And nuclear energy is the energy at the center of an atom in that nucleus. If it breaks apart or something, it's going to release energy. Let's talk about kinetic energy versus potential energy, the first one being kinetic energy. Now remember that kinetic energy, this is going to depend on the object's mass and its speed. If we have an object, then if its mass increases, right, then you're going to get the energy increase. If its energy increases, if its speed increases, you're also going to get an energy increase. So either way, if you have an increase in mass or an increase in speed, then you're going to have an increase in energy. For instance, let's say we have 2 different types of balls. We have a bowling ball and we have a soccer ball, right? Badly drawn soccer ball. If we have these, the bowling ball has more mass and therefore it is going to have more energy. Now let's think about this if I had, if this one were different. Let's say that this was not a soccer ball, again, badly drawn one, but another bowling ball. And this bowling ball is going faster. So this one's going really fast. This one's kind of just meandering along. Which one of these is going to have more kinetic energy? Well, it's going to be the one that's going really fast, this guy here. Because he's going really fast, he's going to have more kinetic energy because he has a greater speed. And potential energy. Okay, remember, potential energy is the energy that an item has, right? If I have a ball and I'm holding it, does it have any kinetic energy? No, not at the time, but it does have a potential energy. That energy is sitting there waiting to come out. If I drop the ball, it now has kinetic energy and it's lost its potential energy. Let's take a look at these three pictures. Now, each of these shows an example of potential energy, right? So in this first picture, right here, we have this rock that is balanced on top of this other section. It has a potential energy to fall. Now, if it were to fall down, it would have its kinetic energy, but right now, up there, it is showing it has potential energy, and gravity is actually the force that is playing on it. Remember that gravity, also known as gravitational potential energy, is pulling on it. Now, the two things that are playing a part in that, of course, are the mass of the boulder and how high it is. Both of those things play a part in determining how much potential energy that rock has. In this rocket, there is chemicals in that fuel. And so within that fuel, there are molecules that have potential energy. When we apply ignition to it, we light the ignition, then we're going to have that energy get released. But right now, just as a fuel, it is a potential energy. And another form of potential energy is shown here in the arrow being, the bow being stretched back, right? You have that energy that is potential that comes from stretching or even compressing or pushing against something. Those are a potential energy. That energy is stored. When it's released, then you're going to get that release of energy. Think back to like an earthquake, and you have that energy from the plates that are pushing against each other or grinding against each other, and that energy releases. Same kind of thing. You have that potential energy inside there, but when the release happens, then that energy is released out of there, and that's no longer a potential energy there. Okay, next up, we're going to talk about energy conversion and conservation. So, conversion and conservation. First up is going to be conversion, and as we know, energy can change, and that energy change is called conversion. So it can change its form. Let's take the idea that we have a matchstick, right? Let's give it some color here. This matchstick, when it is lit, it can actually change into light and heat, and this is a conversion that happens. Now, there's 5 conversions that happen here. I am not going to be giving you a question that is this specific question, but this does apply to one of the questions on the test. So, in this case, the conversions that happen within a match is plants convert the energy from the sun into the chemical energy. The energy is stored in the form of sugars in their cells. Then a person might eat food that comes from plants or from animals that have eaten plants. Person's cells can release the plant's chemical energy. Some of the chemical energy is converted into kinetic energy. The person uses the kinetic energy to rub the match over a rough surface to strike it. The friction between the match and the striking surface produces heat, and the heat provides the energy needed to start the chemical change that produces the flame. So again, I don't need you to remember all that. What I need you to realize is there are all sorts of different steps in converting energy. It's not just the strike of the match that the human makes, it's the fact that there's all these other things that converts that energy in order to be able to strike that match. Now, potential energy can be changed into kinetic energy, and then it can be changed back. think here about this picture here, right? We have our ski jumper. So as he is sitting up there at the top, before he's starting down the slope, he's going to have that potential energy. It's not kinetic energy because he's not moving yet, but there's that energy stored inside him. Then as he falls down the slope, as he moves down there, some potential energy is converted into kinetic energy, right? That potential energy that was up at the top is now being shown as kinetic energy. And when he takes off from the ramp, because he jumps up here, then that energy is changed back into potential energy. All right, here's another example of converting potential energy to kinetic energy, back to potential energy, to kinetic energy, whatever, right? So here we have water behind a dam, and this makes sense because we have the Hoover Dam here. This is how it works, right? The water is held behind the dam, and it has that potential energy again. It's not doing anything there, but it has the potential to be energy. That potential energy is converted to kinetic energy when it moves through the tunnels. And then the kinetic energy is used to turn the turbines. How many of you have actually been down in there? You can see these big giant turbines, right? So it's used to turn those turbines. This is that mechanical energy that we talked about earlier, which is converted into electrical energy by the generators. Now that electrical energy is transmitted through wires, converted into many other forms of energy. So this is the transfer, the conversion of energy. Now, though water is one of our best uses of energy, there are other kinds. There is coal burning and nuclear energy and those sorts of things. Now, the difference, though, between things like water energy compared to using coal, which is burnt, is that fossil fuels, which is our coal, cannot be replaced once they're used up, right? Once that coal is burnt and once it's used up, it's no longer able to be replaced. Water is a renewable resource. Coal is a non-renewable resource. Now, you may remember back, I hope you do, to the law of conservation of mass. Well, there also is a law of conservation of energy. Law of conservation of energy, right? Same idea, though, that energy cannot be created nor can it be destroyed. So this rule is true in every case that we know about, and that is why it's called a law, right? It may sometimes look like energy is lost, but it's not. It just changes form. So in this picture, like here, right, we've got someone moving. They're creating kinetic energy, which is converted to heat, which is also converted to sound. So these are conversions that occur. You won't necessarily see the same kind of energy, but it still is a form of energy. Some energy is not converted into a useful type, and unfortunately that's just the way it works, right? Don't we wish we could use every bit of energy that is produced, but sometimes it's not. So useful energy is almost always less. So useful is less than the total amount. Now, one way that we look at this is something called energy efficiency. How many of you at home have your 3-star appliances or whatever they call those, right? So they've got these star ratings that talk about how energy efficient they are. Well, energy efficiency is the measure of usable energy after the energy conversion. So again, let's talk about things like your dryer at home, right? That's a typical one that has a higher star rating for energy conservation. Because what it's saying is that it uses less energy to operate and do the same job that a less energy efficient item would use. In this case, if I have clothes in the dryer and the dryer gets turned on, and it's going to use a less amount of energy to dry the same amount of clothes for the same amount of time. Our last section is energy and technology. So we're going to to talk about how technology is helping us to use energy more efficiently. Energy is conserved, and technology improves the way that we make those conversions, right? Many common energy versions, most of the wasted energy is released as heat. We get a lot of heat off of different things like batteries and light bulbs and that sort of thing. So we get that wasted energy. Well, we have more efficient lighting options. One option there is the LED. Now, LED, or light emitting diode, is being used often, a lot more often. In fact, the new lights that we have here in the science lab are actually LED lights. They use less energy and produce more light. So they have that advantage of converting almost all of the electrical energy that they use into light, much more efficient. Efficient cars are also coming on the market. I'm sure you've heard about hybrid cars and what they can do. So a large percentage of the gasoline's chemical energy, when you use a gasoline car, it's not converted into moving the car forward in that kinetic energy, right? So it's wasted on heat, as well as applying towards heat on the tires and the brakes and that sort of thing. But the more efficient cars are making it so that you don't have that much waste and you're able to have better fuel efficiency. Another way that technology improves the use of our energy resources is, again, remember those non-renewable resources, things like coal, oil, and gas, those sorts of things. Again, they're non-renewable. Once they're gone, they're gone. There's nothing we can do about it. But however, at this time, we are trying to go towards energy that comes from other resources. Remember, we talked about water. Water is one of the big ways that we can use a resource that allows us to produce energy without using a non-renewable resource. And there's two others. There is solar energy, such as the panels on this house. These solar energy cells, they actually collect the sunlight, which allows us to use the energy that the sun produces, which is, again, a renewable resource. We're not going to run out of that sun's energy. A couple other great things about solar energy is it's a clean form of energy. And it's also very quiet. We don't hear anything that occurs on this. We use a lot of solar energy here in this area. How many of you probably have some of these on your roof in order to heat your pool or even your house? They are not particularly efficient at this time, but as solar energy technology improves, we are getting more and more use out of our solar energy. We're actually expecting that in not too far future, we'll be able to use about 40% of what they can collect. Now, our last form of renewable energy is our wind energy. Wind energy is a kinetic energy, and in the past, these have been used in windmills and to grind grain and pump water. Now we use it to generate electric energy. Large wind farms can be in open areas, and they move these rotators slowly, which produces energy. Okay, it seems I can't win with the good luck salutation, so I'm going to just continue it and say good luck on the test. Happy studying.